Alright, hello. So I'm back with another tutorial for the COD Robotics Club, and we're running this Linux machine. It's on Ubuntu 20.04, and I just finished installing ROS. So this is assuming you have done both. If not, you might want to watch the other two tutorials first. But basically, we're just going to go here, type ROS Tutorials. Open this up. Installing and configuring your ROS environment. This ROS environment is basically the folder where all your code lies, and it cannot go past it, and nothing else can call upon it. Actually, I don't know if that's true, but generally speaking, you don't have stuff interfering with it, like that's outside of your folder, and then you don't have it calling on like your other folder unless it's covering like device, like you're calling on the device's like code. So like for example, if I connected the camera, then it'll call on the camera's files because it needs the camera's code to function. But here, so it tells us what we have available for us within our environment. Here we have ROS version 1. That is good. We want ROS 1 because ROS Noetic is on ROS 1. We might switch to ROS 2, but I don't think we're switching to it this year. We want Python 3. This is nice to have. It's a good thing to have. We want a newer version of Python. And the rest of this stuff, I don't fully understand, so we'll skip that. Just make sure it looks like something like this before we move on. And make sure you don't get the $sign. So to make sure we don't have to run this on our own all the time, we're going to go to gedit.bashrc, which runs commands for us every time we open a new terminal. So it automates the process. I already copied and pasted it here when I did the ROS installation. So if you followed me like line for line, you should see it down here or somewhere up here. While I'm at it with this bash file, I'm going to add a comment saying geos added commands, just so I know that's for me. Now I'm gonna, before I close it here actually, so it's saved here, you can see because the asterisk's gone. So if I add like A, you can see that the asterisk goes there, so that means it's not saved. I'm gonna just drag it over here and you can see it here. Now if I go back here and I start typing, like I can't do anything. I hit enter, it's not running my command. I do let's say I'll just do the same command from before, print and grep ROS, and nothing happens. And that's because you're currently running this command. Every time this happens where your name's not popping up down on the next line, it means it's currently running another command. So you basically can't do more commands here unless you stop this one, or if you want to keep going, then you make a new tab and then you can continue typing here. But let's say you want to keep going here and you're wondering why like you can't do stuff. It's because this command is still running at the moment. It's on and you have to terminate or kill it. And you could press this X button over here to close it out, but you could also, for any command, not just like this file or whatever, hit Control C, and then you see the file disappears. I'm no longer editing it, and now my name popped back up here. All right, continue on. This command, so it's saying make directory, and this -p means that you can also make a subdirectory, which is going to be this one right here. So if I open up my files, it's not cat can workspace, and that's the important one. So mkdir means make new directory, -p means you can create a subdirectory. This tilde means you're creating in the home folder, which is where my thing is here. You can see the tilde right there, and then you can see here it says home right here. So now I'm gonna paste. I open this up, and now cat can workspace, the folder exists, as well as the source folder. Now I'm gonna cd into it, so I'm changing into this directory, and now I'm in my catkin workspace. This catkin workspace is going to contain all our code and allow stuff to work together. Now we're going to catkin make. This is what builds and compiles your code and does installation stuff. You can see it does all of this stuff for us. It's nice. It basically says and does the code is supposed to work. It tells the operating system that. And you could use other stuff like Visual Studio or Idle, or there's like other IDEs, And basically all these things just make it so that you could run code. This is nice because we're able to run it on the Linux Ubuntu terminal itself. And it's like native to it, so it makes it nice. And also we're kind of forced to use it because ROS uses only that. And now that we've made this directory, we have to source this file, which I'll show right now. Catkin workspace devil setup.bash. We got to run this file every time. Catkin shell bash. These are comments. And then look, it says setup directory, blah blah blah. So it runs stuff for us, and we need to call on this every time. Look, it calls on the catkin setup directory, setup.sh. So we need this. It's important. We got to run it to run all our other commands. And in order to make it so that we don't have to do that every single time, we're going to do it the same thing we did last time. gedit dot bash rc. Oh, I typed that wrong, and I just made a new folder. So let's remove. Rm means remove dot ashrc. Oh, I guess I never saved anything, so it never. Yeah, that makes sense. Okay, cool. So gedit dot bash rc. And now we're back here with the infamous .bash rc folder. And now we're going to copy and paste this line next. So now we don't have to worry about copy and pasting this line every time. There we go. Save, close here, and now we got access to typing again. And now we're going to echo this. So basically, this is an environment variable, meaning it finds us within your computer files, and this $, and then like this specific command, it searches for that and tells you like where your packages are going to be installed. And for here, for us, it's going to be an opt ROS noetic share, which makes sense here. Look, it says opt ROS kinetic, ours is noetic share. So now we could go to the next part. Oh, and also we could ignore this because ROS melodic is the version before, and then earlier means all the versions before that one, and we're one version ahead, so this is not our concern. ROS file system tutorial. Navigating the ROS file system. Tutorial inspect, blah blah blah. Please install it using this. Okay. So I don't know if the full installation gives this to us already. We'll find out. But replace distro. Remember, replace the angle brackets as well. Actually, I'll show that. So if I do noetic like this, it says no such file or directory, and that's because I left the angle brackets there. Make sure you delete those. Zero created, zero newly installed. Okay, yeah, so we already had that. Just make sure you do have those. So if I do ROS pack find tab more, yes. Okay, cool. So this is all the stuff it can find. Oh, and I hit tab twice. So if I hit tab twice, then like it lists all the things you could type after for it to find. So it found all of this stuff for me, which we're gonna learn about quite a bit. We're gonna learn about RViz and plugin tutorials. Hopefully not joint state. I don't want to learn that. But these are like a lot of packages we could use. Honestly, you won't be needing to ROS pack find all of these. ROS CD is part of the ROS bash suite. It allows you to change directly to a package or stack. ROS CD CPP. Okay, so let's see this. Okay, it takes us all the way there. But I don't think this stuff is that useful. Oh, PWD means like it shows what directory you're in right now. Yeah, so ROSPAC find like lists all the like the whole way to get to your thing. But this stuff's not really that useful because you're not going into these folders themselves to change them. You're gonna be like applying them to your folder and to your workspace. Let's go back to the beginning. Then we'll ROS ls tab twice, and there's even more packages now. Jeez. Oh, and you press yes, and it keeps listing more. Like you can see, it says more here. Oh, wait, ROS LS tab. So I hit Y, and it shows more, and I hit Y again, it shows more, and I hit N, and it stops showing. So this is not really that useful, or at least for now, but it might be useful once we start going into more advanced stuff. So I just want to cover that. Okay, so this is listing just about like how the structure of your workspace is gonna make up. So Catkin workspace, we're gonna put stuff. This package might have a structure that looks like that. Yes. So packages is basically like one folder that's meant to do one type of code. So you're gonna have your workspace here, right? Which is this Catkin workspace. Then source, so that means we open up source, and then we have our cmake lists.txt here, and then within this source folder is gonna be the ROS package. And so then within here, there'll also be package XML and CMakes. And you're going to need like CMakes and package XML for everything, because this stuff helps you like build stuff. Move to trash. Okay. And then you could have like 20 or 30 packages within just here. Creating a Catkin package. Okay. Oh, let's say we're about to make our own package. So we're going to change into the source folder, and actually if I do this command, oh, it still does work. Okay, cool. So you can just copy and paste and it'll take you here. Now use the Catkin create package script to create a new package called beginner tutorials. Okay, we're just gonna copy and paste. Okay, it did stuff. So now if we go here, Catkin workspace source, this is our package. So if we go up here, let's go home, Catkin workspace. It's this folder right here, the workspace folder. Then we go into source. That's our source folder right here. Now you can see the CMake list here, which I'll show the code right now. It does all of this stuff for us. Very helpful. We don't got to worry about that. We go to beginner tutorials, which is package 1, and then it has its CMake list and package XML. And this is what XML looks like. It looks like a lot like HTML. And you're gonna end up, I think they're about to have us look into this, so we'll back out of that for now. Oh, and it also has its own source include, since it has its own launch folder, which we'll go into later. So we made the folder. I'm gonna try to run this. Yeah. Now you need to build the packages. Okay, so every time we make a new package, we gotta build again. You gotta run catkin make so that our package can have all the capabilities. Select traversing package. All the capabilities we need that CMake does for us. It lets us install, build, and source the code. Okay, depends one. You're not gonna really use a lot of these because you could just use like ls, but it's gonna list here what dependencies it uses, which means like it needs those. Okay, right. So now we're gonna go into package XML. So we'll go here, get tutorials, open this up. We'll have you cover this side, and this is the example. So boom, maintainer Giovza, and I don't want to put my actual email, but you put your email here. This is like official stuff, so like if you're putting stuff online, you're posting it, which hopefully we're not posting it, or like people are using our code, because the only people that be using our code are the people in our competition. So you don't really need to make this like look that neat, but here we'll put license like Giovza, whatever, license to me. Most of this stuff. Okay, here. So this is what it depends on. So it uses ROS C++, ROS, Python, and then std messages we'll learn more about later. And then it uses catkin. So this basically, like, you put here what's the code you wanted to use and stuff. Yeah, and they are right about that. So the build tool that helps us build stuff will separate that. The dependencies will separate that. The stuff we export out, which is usually the same as these other two, you separate like that. Save, close. And then we could also customize the CMake list, but whatever. And then we don't need the video. Build the package. Okay. So it's asking us here, source opt ROS kinetic setup.bash. We don't need to do that. And to prove that, because I should have done this before, gedit dot bash rc. Now we could go here. We're gonna copy and paste this. Instead, we're gonna type echo, which just means it prints out on the terminal. So to show that bash rc does that every time, I was gonna say, if we continue to remember the source your environment setup. So we close that, open, and look, it tells us, double dash setup dot bash. Oh, okay, I see why. Good thing I figured that out. So yeah, that's not a directory. So we need to gedit dot bash rc. So we got to go here, devil. We need to do tilde slash catkin underscore workspace. Okay. Tilde slash catkin underscore workspace slash. And then we'll just copy and paste this part. And now it should do this for us. Sorry about that. There we go. Now it does that for us. Okay, cool. So now it runs those commands for us. So now we don't have to worry about typing this every time we're doing something. So we did this command, or now it does that for us. Finally, something we could do. And then we could do ls source, which lists stuff in the source folder, which is just these two things. So that's these two here. You should see that there's a folder called beginner tutorials. You cannot build that package using catkin make, which we did do that, I'm pretty sure. If I type catkin underscore make, oh, we did not build it. Okay, interesting, because if I run the command again, yeah, then it just says it's already been done. Okay, we just move on. Just, I think they had us create the package, then build the package, but they had us build it last time. So we have these tutorials installed. I'm gonna quickly go through these because on the next slide it's gonna be explained more, and I don't want to explain it to you when you don't have the full picture. So if I hit ROS core here, it runs, but you can see I'm not in my catkin workspace, which is where we want to be. So I'm gonna cd out, which I was just there, but we'll cd back into catkin workspace and run it here because, well, it's just procedure. So running here, you can see this is the master URI, which is my thingy, and we don't gotta worry about that because it worked for us. ROS no list. Okay, so now we had to open a new tab. Now this tab is connected to this one over here. They're linked, and we know that because if we hit ROS node list, it says here ROS out. Now if I close this ROS core, and I go back here, and I hit ROS no list. Error, unable to communicate with master. This is the master, by the way, ROS core. ROS core is the center of all of our code. And now if we do this, it tells us what we're publishing, which is a message. Who we're subscribed to, we don't know. And you'll find out why it doesn't know who we're subscribed to. And then services, which we'll also go over. So ROS run. ROS run allows us to run packages. And by run, it just means executes them. So we open this up, and look, we got a turtle. And it lists like some information here, the position. So we have that window, and we do a new terminal. Now we do ROS node list again. It now lists both nodes, the ROS out one, which is from here, and then turtle sim from here. Each one is a node. This is one node, and it's running right now. You can see I cannot do any more commands, and this is also another node. And both of these nodes are sending out information. This time remapping the argument. Okay, so I'm gonna close this, the one with the turtle one, and we're gonna do this instead. And basically we're just calling it a different name. And I go back here, run it again, and now this time it's called my turtle. Why? What happened? Why is turtle sim here? Maybe I had to close this. Close this. Control C. Close this. New tab. Sorry, it looks like there was a ghost node. So now ROS node info out. Ah, shoot, my bad. I need ROS node list, right? Yeah. ROS node list. It's still saying 3. Okay, that's strange. Well, we'll ignore the ghost node, and hopefully it doesn't interfere with anything. But you can see now we're pinging it. So now we are sending a message to my turtle, so that node. XML. Okay. So ROS core provides name service for ROS, blah 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 blah. And basically you need that to run everything else. ROS node. Get information about nodes, which is these things. They just allow you, they're like little scripts that allows you to do stuff. All right, topics. So we have ROS core running. You can't run 2 ROS cores, by the way. If we run another ROS core, it'll tell us no, we can't, because there's already one. We need to rely on 1 ROS core. Instead, wait, turtle sim, turtle node. Didn't we have that? Yes, we're running that already. Okay, cool. Now we're gonna run this one. ROS run turtle sim. Now, this is a node right here, okay? And this node, we're gonna open this up. This is another node right here. This is this node. This node is this, and this node can now move the turtle around. You can see I'll try to make a little circle. Oh, I really messed that one up. So you can see I was able to use this node, which you can see here says use arrow keys to move the turtle. This node publishes information out into the ROS core, and then the ROS core sends it back here and is able to tell it hey, you got a new information update. Which I'm not being too specific. You might need to run these commands to install stuff. I think I have it already, so I'll just run this. ROS run RQT graph. This is one of the reasons why we're using ROS. It allows us to visualize what's going on. It lets us use tools to see what's happening. So you can see the telap, which is the keyboard one here, is sending this information, command velocity, to my turtle, which is, it says here turtle sim, but it's because I renamed it over here, my turtle, uh, my turtle. So for me, it's called my turtle. But you can see it is sending information to this node. So this oval shape, which it means node, is sending information, and the arrow is pointing this way, to my turtle, and they're able to talk to each other. Why? Why is there no topic? Um. Okay, here we go. And topics. Okay, so this topic is in charge of receiving and sending out information to nodes. So this node sends information to this topic, and then this topic spits it back out to my turtle. And then this is a list of commands you can use. So echo gives messages to us. Bandwidth, which we're going to need to use because we're going to get judged based on how much bandwidth we use. I haven't really used hertz. List. Oh, actually, yeah, I have used list. It just, yeah, it gives you all the topics. You could publish data to it and then get the type. Okay, so now we'll go on a new tab, which now we're on like 4 or 5 tabs. And we'll ROS topic echo. Control Shift V. And hydro and later, so that's us. We get this one up here. Run that. And now if I go back to this one and I start pressing buttons on the keyboard, you can see turtle move some more. And now if I go back here, you can see this is the data that gets published every time I press the key. So we did here XYZ 0. I'm gonna go back here, press once up, and then we'll see here. You can see it just said X2. So this topic is receiving this information. It receives this right here and spits it back out to the other node. Oh, cool, cool, cool. So we could go back to RQT graph, refresh, and now you can see here. Now this topic is receiving this information from the telap, which is this node right here where we push the buttons on the keys. Takes this information and sends it to both the my turtle node, which is this drawing, this canvas right here, and it's sending it to this topic, which is basically this thing right here, which is asking for the topic information. So these topics are key to distributing information. They're like the middleman. Okay, yeah, we could run this. Yeah. So you can see like how many publishers, so who's sending out information. And for the ROS graph, all of these are sending out information. And I think that's 4. 1, 2, 3, 4. The fifth is probably like ROS core itself. And then turtle sim pose, which is asking for the position of the turtle. It is these two. Oh no, publishing, giving information. Who's publishing? And then here's subscribers. ROS topic type. Okay, so this is just like you get what type of information is listed. So it's geometry twist, which you can see here. Geometry twist. Continue, publish. Oh, okay, yeah, this is cool. So you could have the topic publish information, which I was talking about earlier. And where is it? Oh, okay. I missed it. Let's run it again. I think the -1 means for 1 second, right? We'll find out. We'll do -5. Oh, messed that one up. We'll do 1. And you can see it's publishing information. It's sending information to this topic. And then now it's made a full circle. This option causes ROS to only publish one message, then exit. Okay. The name of the topic to publish to, yep, and then the type of message, yeah. So we'll do this. And now, look, the turtle just keeps going forever. And if we wanted to stop sending information, we hit Control C. Oh, I should have done that earlier. We're going to keep it going. Now we're going to go to the graph and refresh. And now, why? Oh, it's because they don't have the topic showing. So if I just do nodes, then yeah, you can see they're all sending all types of information. So this is sending information to these two. And then this one's also sending information to both. But if you put the topic in, then you can see it's just one topic is sending the same information to these two, but it's getting that information from these. And then echo would just display that message. Yeah, this is what I was looking for, HD. So basically, this just shows how fast the information is being published. So it's being published 60 times a second. We'll run this one. Remember, we're later than ROS Hydro. So, new tab. We're getting quite a lot of tabs open now. You can't even read them anymore. Oh, it just shows the messages. RQT plot. This is another tool. Now, honestly, I don't even fully understand this. I'll run it to show you guys it, but I haven't really used this much. Am I not running anything right now? Where's the turtle? The turtle's moving. Where's my information? Yeah, I don't get it. I don't know what it's supposed to do. So close it out. I did it right, right? Was I supposed to do it in somewhere else? I don't know. But like it basically like lists the value of the information you're publishing. So like right here you can see it was like 5.5 at the 6 second, and it dropped down and it went down to like 3 point something, but then went back up to 5. It's because they're like spinning in a circle and stuff. Right. Okay, so after looking through the ROS tutorials, we are through number 6. So we've done 6 of the beginner tutorials. Now this advanced intermediate stuff, it's more niche. Like some of us, we're not gonna create a package. We're just gonna add on to other packages. Some of us are not gonna use two machines. It's just gonna be like motor people or stuff like that. Like it's more specifically tied to like wireless and IT guys. So like stuff like that where we're not gonna need a cover, and then everything afterwards is like super advanced, super niche stuff. So a lot of that stuff is not something you need to go over. So I'm not gonna waste your time with that. Our goal is to like speed through these stuff, but still be efficient and like still learn the content behind it. As of right now, it seems we're gonna be done on at the end of September through all the rostings. So that means we'll have all of October, November, and then half of December to go ahead. Last semester, our goal is just to finish ROS by this time, or I guess here, 16. And so that means we'll be 2.5 months ahead of schedule, which is good because that means we have 2.5 months to start learning what we want to do, how we want to apply it, and what specific tools we got to work with. So 1 through 6, the remainders are going to be up until 16 because even these two are data science based. And we got to go over these, which is 7 through 16, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which seems like a lot since we just did 6 last time. That's almost double. But we're going to only go over Python stuff. And then we're going to quickly rush through these. So these three go over the same content. It's just one's in one language, one's in another. and then this one's general. So we're gonna go over Python just because that's an easier language for people to understand, and then we're gonna quickly go over the content afterwards, or maybe we do the content and then do Python. We'll figure it out. But basically, these two are basically one thing. These two are basically one thing. So that's 1, 2, 3, 4, 5, 6 more sections, and then we're done with all of ROS. And you'll be able to say you understand ROS. So that's pretty good. We're going really quick through this, and we got a lot more members. So this is some positive stuff. Good job if you've made it this far. You're gonna learn a lot. Thank you for watching. Thank you, Alex, for editing. Take care, everyone, and I'll go over the rest of the sections soon. Take care. Bye.